All right. Welcome back, everyone. We're doing something a little different today. Uh,
Different? How so?
well, we're always talking about current events, right?
Yeah,
And
like
the latest news and stuff.
yeah, breaking news and political happenings. That's usually our bread and butter.
Right. Exactly.
Mm.
So today we're kind of taking a step back in time, you could say.
Oh, interesting. Stepping back in time. Okay, I like it. So where are we going? Back to the dinosaurs.
Uh-huh. Not quite that far back, but we are going to be digging into a topic that involves history and buildings.
History and buildings. Okay. That sounds right up my alley. Give me some more.
So specifically, we're going to be doing a deep dive into this case study.
Big case study, all right.
That,
On what exactly? What's the subject of this deep dive?
it's this building in New York City, the NYU 79 WSE building.
NYU 79 WSE building. Okay, I'm not familiar with it. What's so special about this particular building?
Well, it's a pretty old building, like historically significant, and
Ugh, historic building preservation. I see where we're going with this.
yeah,
Always a fascinating subject.
exactly. And these days, historic preservation is a big deal, right?
Absolutely. It's not just about nostalgia. It's about understanding our past, respecting our heritage.
Yeah, and these buildings, they've seen so much history. It's important to, keep them around.
They're like living museums in a way. They tell stories, reflect architectural trends, hold memories within their walls.
Right. And so that's what we're going to be exploring today, the process of how they go about preserving a historic building.
Sounds like a plan. So, what kind of information do we have to work with? Where are we getting our insights?
Well, we've got some reports from experts who've been working on this NYU 79 WSE building.
Excellent. So these reports will give us a glimpse into the behind the scenes work of historic building preservation.
Exactly. They've been doing a lot of material analysis and performance testing and all sorts of things.
Material analysis and performance testing. Sounds like some real detective work is going on here.
It is like they're trying to figure out, what this building is even made of and how well those materials are holding up, after all these years.
That makes sense. Before you even think about restoring something, you need to understand what you're dealing with. What's the foundation, so to speak?
Oh, yeah, exactly. So I guess that's, kind of the mission of our deep dive today.
To uncover the secrets of this historic building and see what it takes to bring it back to life, I'm in.
Okay, so getting into these reports, right? One of the first things that jumped out was this mention of non-standard sample conditions.
Non-standard sample conditions. Okay, now that's interesting. What does that even mean?
Right. Like, what's so unusual about the samples they took from this building?
Well, think about it. This isn't a brand new building with pristine materials.
Yeah, of course. It's old.
It's centuries old. Who knows how many times it's been repaired, modified, patched up. You're not dealing with a textbook example here.
So the samples themselves are kind of wonky, like not the usual shapes and sizes.
Exactly. The reports describe the samples as being irregular, maybe different layers of materials from different eras all kind of mashed together.
So they couldn't just use like the typical off-the-shelf tests.
Nope. And that's where things get really interesting. The report specifically mentions they couldn't use ASTM C177.
ASTM. What was it again?
C177, it's a standard test for thermal conductivity.
Oh, right, right.
But it just wasn't suitable for these unusual samples. So they had to go with a different method, ASTM C1044.
Okay, so they had to get a little creative with their testing methods. But hold on, rewind a sec. Thermal conductivity for bricks.
Yeah, thermal conductivity is a big deal when it comes to buildings, even historic ones.
I guess I never really thought about bricks having like a thermal conductivity rating. What does that even tell you?
Well, thermal conductivity is all about how easily heat passes through a material.
Oh, okay. Like how well it insulates.
Exactly. So for a building like NYU 79 WSE, knowing the thermal conductivity of the bricks can help them figure out how to keep it energy efficient.
Right, because you don't want heat just leaking out through the walls, right?
Right.
Especially in New York City, where you've got like crazy temperature swings.
Exactly. So knowing how well the brick breathes, so to speak, is crucial for maintaining comfortable temperatures inside.
So they use this special test. And what do they find out about the bricks? What's their thermal conductivity like?
Well, that's the fascinating part. The test showed that the bricks actually have a surprisingly high thermal conductivity.
Really, higher than they expected.
Yeah, meaning they transfer heat more easily than they initially thought.
Hmm. So what does that mean for the restoration?
Well, it means they might have to think a little differently about insulation.
Right, like maybe they need to add extra insulation to compensate for the leaky bricks.
Precisely. It's all about finding that balance between preserving the historic character of the building and making sure it's functional and comfortable for modern use.
It's incredible how much thought goes into this. It's like way more than just slapping on a fresh coat of paint.
Oh, absolutely. And thermal conductivity is just one piece of the puzzle.
Oh, right. There's other stuff in the report too, like water vapor transmission.
Yep, water vapor transmission. That's about how easily moisture can pass through the material.
Okay, so why is that important for a brick building?
Think about it. New York City, rain, snow, humidity, you name it.
Right, a lot of moisture to deal with.
Exactly. So if the bricks are too permeable, moisture can seep in, cause damage, mold, a whole host of problems.
Ah, that makes sense. So they need to know how to protect the building from the elements.
Exactly. And then there's another fascinating test they mentioned, petrographic analysis.
Petrographic. I'm not sure I've heard that one before.
Think of it like looking at the brick's DNA under a microscope.
Okay, that sounds pretty high tech.
It is. Petrographic analysis lets them see the composition of the brick, how the minerals are arranged, all the tiny details.
And what does that tell them?
A lot. It tells them about the brick's strength, its durability, how resistant it is to weathering.
Wow, so it's like a window into the brick's past and how it's likely to hold up in the future.
Exactly. They can see if there are any weaknesses, any areas that might be prone to damage.
So it's not just about preserving the look of the building, it's about understanding how it works, how to keep it strong for the future.
Precisely. And all of this analysis, these tests, they're not just for fun. They're used by the experts, in this case, a company called Infinita Lab.
Infibeta Lab, okay.
They take all this information and use it to come up with a plan for the restoration of NYU 79 WSE.
A roadmap for bringing this old building back to life, so to speak.
Exactly. They're not just restoring the building, they're preserving its history, its story, making sure it can stand for another 100 years.
Wow. It's amazing to think about all the work that goes into it. So next time I work by an old building, I'll definitely be looking at it with a whole new appreciation.
I think we all will. And, we've talked a lot